We want to prove f is constant if the following inequality holds. So we know that f derivative of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. Now if we look at its absolute value, that will equal the absolute value of that. And actually I don't need the absolute to be on the outside here. Okay, that's a little bit neater. Now that will equal the limit as h goes to 0 absolute of x plus h minus f of x close absolute all over absolute of h. Now this here is what we have on the top. So this is less than the limit as h goes to 0. So basically we can drop the f's and add a square. So x plus h minus x squared all over absolute of h. That's equal to the limit as h goes to 0 of h squared over the absolute of h. Now that's equal to the limit as h goes to 0. This whole thing will always be positive, but you could think of h squared as absolute of h times absolute of h over absolute of h, so they can cancel. So that's the limit as h goes to 0, the absolute of h, which equals 0. So therefore, the absolute of the derivative of x, regardless of the x, is equal to 0. And that can only mean one thing, that the derivative was 0, which could also only mean one thing, that the original function f of x is constant. Okay, that's nice enough.